space cybersecurity is no longer an option. It's a necessity. For sovereignty, for resilience, for the future. Global threats are rising. Space is the new battlefield. Are you ready? With more than 60 high-level speakers and experts. Welcome to CYSAT 2025. Hello, everyone. I hope, you found your place in the room, and there are still guests arriving upstairs. We are glad to have you here for day 2 of CYSAT 2025, and we will continue digging deeper into cybersecurity for the space industry. And we are starting right now with one of our high-level speakers. It is Jacques Kruse Brandao, who I am welcoming on stage, Global Head of Advocacy at TÜVIT. Give him a warm round of applause, thank you.
Hello, good morning.
I should therefore mention that TÜVIT is one of our sponsors, and we thank you for that and allowing us to organize this nice event. The floor is yours.
Thank you very much. So, what I would like to talk about today is dual use and the use of a cybersecurity certification framework and the advantages of using such kind of framework. But first of all, there's always the question is, what is dual use? What is meant with dual use? So we will start with that. We also go into the threat landscape again. Why do we think about this? And the expected requirements from dual use and from the usual space market. We have a look at the European regulation and standards which have been worked on in the last 10 years on a European level. And we drop that or map that into a concept for secure space systems. Having a look at the current constellations, I think I don't need to tell you anything on that. Everybody knows Galileo, EGNOS, Copernicus, Gauss.com, and now IRIS². IRIS² is interesting because we are talking about governmental communication networks. And this in the context of dual use, we could request, why is this not used by armed forces of European member states? But that gives us let's say the question, what are the use cases behind? Why do we think about dual use? And very easy, think about the use of communication networks for human beings, but also think about the communication network for IoT devices, for everything which is connected in a combat cloud. If we want to fly autonomously drones, you need to have surveillance or situational awareness data, Earth observation data, and they need to be trusted. There is no autonomous drone flying based on trusted Earth observation data. That gives us the question, what means trusted Earth observation data? What is necessary that we trust such data? That there is nobody in the middle, somewhere in the supply chain between the development of the camera which is taking the pictures, creating the data, in the transfer of the data, in the backend system of the data, and nobody was able to intervene or manipulate any kind of such data, that the armed forces will be able to trust such data to make use of them for the situational awareness requirements. So think about these use cases. And it all starts with PNT services. Of course, we need to trust the time, positioning, navigation, information dramatically. This gives us the question, what is involved when it comes to such use cases? And it starts with the components, and it starts with the semiconductor components, the IEEE components, of course, and goes to the secure elements, TPMs, HSMs, etc. And it goes into the technologies, and we talked yesterday a lot about post-quantum technology. We talked about QKD, quantum key distribution, or PKI infrastructures. When we talk about the requirements, very often there is the word COTS, components off the shelf, commercial off the shelf, you name it. But what is the difference between COTS and secure COTS? If you can trust components, there's a certain requirement which comes to it. And it's often in the combination of the requirements related to confidentiality, integrity, and availability. Very often it's based on harmonized standards, because harmonized standards are usually used since many, many years, tested by many stakeholders in many segments, which is the case in cybersecurity. So we have we have a global community looking at cybersecurity, what is best practice to secure assets, data, communication, backend systems, and we should make use of those in each of these use cases. And of course, with every standard, there comes the standardization of test methodologies. And I come to that later, which is we use common criteria for that. The advantages, on the other hand, is if you make use of COTS, then there's a volume behind. Volume means reduction of cost. In the semiconductor industry, cost goes down if the volume goes up. So why not make use of such advantages? My thesis is 85% of cybersecurity requirements, if we think about dual use, are similar. And of course, armed forces have their special requirements, in each member state probably. But 85% from a cybersecurity perspective are probably similar. So think about that. If we would be able to, let's say, demonstrate conformity to these 85%, every DoD can add whatever they want to add. In terms of crypto, in terms of VPN or not VPN, or whatever this is available. So if we standardize cybersecurity or make use of this, there's less adaptation, less discussions in the beginning of a project to define individual cybersecurity requirements. It's more interoperable, and it is tested since many years. So many advantages we can make use of if we do not define the cybersecurity requirements again and again and again. It opens up a market with 27 member states if we make use of agreed cybersecurity requirements. And this not only in space, also that's why we can make use of COTS, components off the shelf, which are used in other domains, in other segments, like automotive, industry, medical, in rough environments, or in the air for the aviation industry. There's a huge threat landscape, but I look today only on one, to the cybersecurity attack sabotage. And there's always human behind. If we talk about safety, there's always the intended use behind the safety requirements. Cybersecurity always means non-intended use. The hackers are looking at the non-intended use cases. Functionalities which are in place and not used, but open to get into the system. From a space perspective, we need to have a look then on the complete supply chain, starting with the development departments which develop the devices, the payloads, the rockets, the satellites, the communication, the backend systems. But then we need also to look at the organizations, we need to look at the products themselves, the ground stations, the antennas, the steering of the control systems, but also the communication between the satellites. So all this is to be looked at individually and to avoid that there are vulnerabilities within this system. Look, you're always part of the system. Nobody of us is offering a complete system. So you're depending on your supply chains, and the supply chain make use of open source components, tier 1 to X, so this is what needs to be addressed. And of course, I don't recall that, but Cyber Insight, they're also here. They published last year a nice study and will publish soon the updated version, as I learned yesterday, and I refer to them similar here to the ENISA Space Threat Landscape report, which have been published recently. And who did not read it, please read it. So, who's affected by cyber threats? We all. As citizens, our governments, our administrations, our armed forces, but also our daily use cases, our businesses. So, because we all make use of these satellite systems. And that's why space is so important. That's why space has such a huge impact on our life. And that's why we define this probably in the EU Space Act as critical infrastructure. And if you asked some months before, it was not clear whether space is critical infrastructure. I think everybody is clear, space is critical infrastructure, and we need to take care and we need to take action. So again, all the stakeholders are involved, and everybody needs to look at his individual part to contribute to the security of our society. The European Commission started 10 years ago an initiative on regulation policies and related standards related to the cybersecurity requirements as a horizontal requirement, because every segment is affected. And it started with NIS1, now it's becoming NIS2, CRA, CSA, and the EUCC as a standard behind that. So it's on the ground, we are affected, so it's not up in space, but we need to look at all these different components. And as cybersecurity is a horizontal, we need to find, let's say, a way of working to go through all these segments by using adaptable requirements for each segment. NIS2 is addressing operators of critical infrastructures. They should fulfill certain requirements, cybersecurity requirements, implement them on a technical basis, on an organizational level, and demonstrate conformity every 2 years, whatever is necessary, depends on you're important or an essential entity. And don't forget, it's not only the operator behind the service, it's also the manufacturing production facilities which are affected by NIS2, and they are becoming critical infrastructure with NIS2. There is a list behind, and please look at that if you are affected as a manufacturer as well. So, ground stations, I don't want to miss that. Ground stations are part of the NIS2. They are mentioned in NIS2. Actually, they are. The NIS2 is currently only looking or addressing companies which are terrestrial and not the space. And that's why the EU space law need to somehow to cover this aspect. The CRA, we're talking a lot about the CRA these days, the Cyber Resilience Act. It's a completely different regulation which is looking towards manufacturers. So manufacturers are obliged to implement a certain set of requirements into their products and services. And it is mentioned that it's about products with digital elements. So everything which is connected, including software. There's only open source components excluded if they are not used commercially. Once you use or make use of software components, like open source components, tier 1 to X in your products, you are the reliable party. You need to take action that your software is secure, whether you use open source or not. And there is a deadline for this. It's December 2027. And if we look at the development life cycles of products, 1.5 to 2 years in a very fast manner. Here is very often longer. You need to take action today and to decide whether you would like to discontinue or continue your product sales from December 2027. You need to take this action today. Don't forget that. The CSA, the Cybersecurity Act, was giving us a chance to, let's say, to create a European cybersecurity certification framework with the prolongation of the work of ENISA, the European Agency for Cybersecurity, but also to create standards behind, certification schemes, which can be used then to make use of them for conformity for cybersecurity implementations. And there was a differentiation between basic, substantial, and high to address different assurance levels in this framework. The Cyber Resilience Act now pulls in the CSA, the Cybersecurity Act, so the Cybersecurity Certification Framework, and their schemes to make use of them in the CRA. So whether you have a product which is of higher requirements, because you're using it in a critical infrastructure with with a huge impact in case of threats, in case of successful attacks, then there might be the requirements to map a higher assurance level to that product. And then there's a possibility to make use of EUCC, for example, as one certification standard based on common criteria. This is need to be defined, and we see here on the right side a lot of security devices which contain a lot of security features, so high-end security components. For example, the chips in your passport, the chips in your credit card are also using these kind of common criteria test methodologies, and they're used billions in the field, billions of times each day in the field, and we are everybody using CC certified components every day. So why not use this in this market as well, more continuously and stringent? EUCC is that certification scheme coming from common criteria and harmonized. The big advantage is we have a harmonized approach between 27 member states. So once you certify, 27 member states, 27 governments should apply to it and should agree what you did and accept what you did, and you can make use of this. There's one missing, which is the EU Space Act. There's a date, which I learned is 25th of June, so not far away. We are expecting that that EU Space Act draft dramatically, because we would like to understand what is in there, and we expect references to the CRA, to NIS2, to make use of such framework. So hopefully you understand now, why is this the case? Why can we make use, or should we make use of such a European cybersecurity certification framework? Because it's used in many other segments, and it's working well. Maybe one question for you. You could think about your own cybersecurity maturity level, whether you are able to, let's say, your company and your products are able to, let's say, implement those cybersecurity features in your products, services, communication, backend systems, organizational processes, and we're looking forward to your answers. It's anonymous, so you can. Nobody's blamed afterwards. I think this complete conference is a huge awareness program, right? There's a trend. Okay. Oh. Still shifting. Thank you very much. I think this gives a quite interesting, overview. Very often it's defined, security policies and processes are clearly defined and documented. There's consistent implementation and employee training. At least 1/3 is doing this. 2/3 are not doing this. But there is also some companies mentioned. We have an optimized version, so really fully integrated into the business strategy. Of course, we are here in our cybersecurity conference, right? So I expect that there are also several optimized ones. So thank you very much on that. Mapping all this to a concept for space systems. What does that mean? Or actually, what is the level, or what is the status today? If we look at the requirements today, there is an individual set of requirements per mission from different stakeholders. We are also talking here about dual use, so thinking about the DoDs in Europe, actually at least in Europe, because we talked about yesterday a lot about European sovereignty and what does that mean. Of course, every component has a possible impact on the security posture of the complete system, and therefore it could have a complete or a huge impact on the complete or on other constellations in that orbit where it's flying. So there's always the risk to others, and this takes also the regulation into account. It's not about the own company, the own products for themselves in their own environment, and whether the production facility is down, it's the impact to the others, because everybody is a supplier to the others. And here in space, in operations, everybody is part of the overall system, so there's an impact to the others. A common cybersecurity framework would allow us to define that such kind of standards jointly. It is comparable. Comparable is a huge advantage if you map your risks to a certain assurance level and then map that standards to that assurance level, for example. It gives big and small players a level playing field, and therefore open up markets, new markets, which are not addressed today. And I think we talked a lot about in the last months, also on other conferences, on use cases, on markets, and how to attract new markets in this field, and how this is a possibility to shift the cybersecurity on one hand and reduce the cost at the same time. A modular approach is the case today. Or no, it's not the case today. It would be a nice feature in the future to make use of modules for different systems. And it's part of this transnational aspect. We see a lot of requirements coming from individual member states, but as I mentioned, 85% are probably the same. Cybersecurity requirements are probably the same. So why not act with a transnational thinking in this case? It would give us a huge advantage for Europe and push the market further in a faster way. And the existing regulation is supporting this. The existing certification possibilities are supporting this. So if we make use of this, of course, because they are addressing several, let's say, security risks, and you define the risk, and afterwards you assess then or map that to a certain security requirement feature set. And this is basic, substantial, or high. And of course, you need to map that to each individual component, application, backend system, communication, and throughout the life cycle. So it's not a static part. If you demonstrate conformity to a certain vulnerability management implementation, you also need to think about how you deal with it in the future. What means vulnerability management tomorrow, and how you deal with this? And I think here there will be the differentiator between the suppliers. To demonstrate conformity only today is not enough. All this is based on a common criteria certification framework which is implemented since many, many years in many countries, more than Europe. Well, it's global, it's a global community. But the advantages here in Europe is that we aligned on 27 member states. And we also thought further. So there's additional requirements in the EUCC, at least some of them, which are implemented now in the EUCC. And that's why it's probably, it's the case at the moment, and the others will follow and implement those requirements accordingly. So we can rely on something which is tested, validated, and we all make use of them, as I mentioned before, every day in our payment activities, for example. So finally, if we map that again here to the space system, we have different security levels, we have different assurance levels. We can make use of them in each and every component. And if you have the chance, and now we are back at the beginning of that presentation, think about COTS and secure COTS. How would you decide if you decide to, if you, let's say, need to decide on certain components, whether you would like to have the secure component or the non-secure component? And here, I think it's clear, you would probably prefer the secure component because you can make use of security features of that component to implement the subsystem accordingly in a cyber-secure manner. The EU Space Act hopefully will support that approach, and that's why I think we are about to start with that and to, let's say, make use of that by today already. EUCC is there, and we can make use of it. As a conclusion, unfortunately, we cannot avoid attacks. And as I mentioned, cybersecurity is national security. It's European sovereignty, and we are all part of it. So whatever we do, we as a community, as a cybersecurity community in space, we are doing good. So if we spread the word, then I think everybody can follow and will follow. Cybersecurity is a precautionary requirement. It's security by design. There is no other way of implementing security afterwards. Detect and avoid is something which we all, of course, need. But without the precautionary principle from the beginning, there's no way to get rid of vulnerabilities. Actually, join forces. Let's make use of the European Cybersecurity Certification Framework, and hopefully this will open up market also for the dual use. Thank you.
Thank you very much, Jacques. I invite you to come here. Thank you. So I will just share your biography and career with our guests. You have previous experience in semiconductors. You're part of EU Commission experts group and in the identification industry for 20 years. You've been part of that. That gives you expertise. I see you sighing. I have one question first. Can we really afford to not to think about dual use? Cost-wise, not cost-wise, but cost-wise, money-wise, can we really afford that?
Well, maybe Iris squared would be a thing which comes to my mind. There is a huge discussion about Iris squared, which is a governmental communication network. So my first thought was, why isn't this used by all armed forces in Europe also? Because we spend billions into this new constellation. Of course, there are obstacles, as always. It's a question of bandwidth. It's a question of architecture, which is good or bad for the armed forces' use. But finally, it's about the requirements. It's about the set of requirements in the beginning. If we would be able to align on such requirements, that armed forces will be able to make use of civil or governmental constellations and services, offerings in the future or not. So if we would be able to align on the cybersecurity requirements, because cybersecurity is a huge important topic here, it's about trustworthiness. Can the armed forces afford to make use of non-trustworthy services? And again, think about the Earth observation data. For situational awareness on the ground for drone flying or communication. If it's not secure, if it's not trusted, no armed forces will use it. But by the way, your future clients, the governments, the critical infrastructures, will also not make use of them anymore. So my prediction is, let's align 85% of these cybersecurity features between these two different or three different players, governments, civil business use cases, critical infrastructures, and MODs. And then I think it will open markets which we do not have today.
We also have a question from the audience. Thank you for putting them on Connects Me. So first question is from Peter Cisak, who is preparing a protection profile for the EU space industry. Would it be working group composed from national security agencies, ESA, EU SPA, etc.? And this questions the governance and the participation of stakeholders to EU policy making.
Thank you very much. I think we need to make use of the complete experts in the field in Europe. In Germany, we have one, which is the expert working group on space systems of the German BSI. And German BSI has a booth here. You can have a look at that. And there's also some publications on that. There's some protection profiles for ground systems and several others already published. There's a link on the booth of BSI, and we have also the link at our booth. But also, of course, we should make use of all stakeholders which have been working on protection profiles in other segments. So I think that's the biggest advantage we have. We have that in Europe. We do not see that often in other regions. So why not should make use of that? And of course, there's also implementation of very good cybersecurity features in Galileo, and make use of that, but it's not for the complete supply chain. And we are now today thinking about the supply chain. It's not about perimeter security anymore. It's about securing each and every node. Zero trust architecture is the burning here, I guess. And of course, the specialists of the European member states are sitting in the EU SPA. Maybe they should more talk about technical requirements, but that's another point. Yeah, let's make use of that.
Another question quickly from Wouter Lover. From my understanding, he says, the problem with common criteria is that the certified chooses what part of the product is assessed and what is part of the environment. Do you think it is a good idea to start standardize and how the environment should be defined for space? To standardize how the environment should be defined for space.
Common criteria is a test methodology. It's not about what you choose in your product. What you choose in your product is the question of what is available in terms of in terms of components. So, of course, there is more components available if there is competition in the market, and then you see other components offering similar or similar product features. So, but you can choose whether the product is certified or not, whether it has the cybersecurity features implemented properly or not. I think that would be the answer here. There is no common criteria does not impose you to use a certain product. Otherwise, there was a need, for example, for one product in the beginning. Yes, maybe, but then you should ask for that feature early, and then there's probably someone offering you that service in a secure manner.
And one last question from James Pavor before we derive too much from our schedule. A question to the Global Head of Advocacy that you are. How can SMEs, cybersecurity researchers, civil society organizations, and individuals most effectively engage with the development of this pan-European strategic decisions? Well, we first shall mention that there is a platform entitled haveyoursay.eu that allows any citizen, stakeholder to share their view on any ongoing process.
Exactly. So the advantage of European regulation is that everybody's asked to participate in the discussion at the table. So every NGO, every individual person is probably able to answer European consultations on the European website of the European Commission. That's one possibility, so also for SMEs. Unfortunately, SMEs do not have often the capacities to participate that, but this is funded very often, so please ask for funding in that case. Researchers, of course, they are also they have the chance to participate, and they do. They do. We see them in several other segments, and I think there's from June 25, there will be the chance to contribute to the draft version of the European Space Act. As I learned, it's already discussed that it will be an act. That means not a directive. A directive needs to be transposed into national law, and an act is immediately effective to all 27 member states later on. So that is a huge advantage in terms of harmonization, in terms of availability of products. As I mentioned, you do not need to decide on the requirements individually, but the pan-European part here is interesting. Of course, in space, we are not European-centric, right? We can think about it, but I think this is not the case. So, of course, it is important to align requirements with international stakeholders, with other stakeholders. And as we are affected in between even the regions, I think there is the need to discuss this also with other regimes. There's no way out to, let's say, have peace in space.
Thank you very much, Jacques Kruse Brandao. We can give you another warm round of applause. Thank you very much.